So just have a look at page 58 of that worksheet. So under question 11 here, this is actually March 2022 P42. Positron emission tomography PET scanning obtains diagnostic information for a person, and this information is used to form an image. PET scanning uses a tracer. Now explain what is meant by a tracer here. A tracer is just simply a substance containing radioactive nuclei that is absorbed by the tissue being studied. Okay, so this is what a tracer actually is. Specifically for PET scanning, you want a tracer that emits beta plus particles. Okay. Then after that, in part B, PET scanning involves annihilation. So what is meant by annihilation? So this is the definition for annihilation. So for your case here, annihilation is simply when a particle interacting with antiparticle so that the mass is converted to energy. Annihilation is when a particle interacting with its antiparticle so that mass is converted to energy. All right. Then in part 2, state the names of the particles that are involved in your annihilation process. So during your annihilation process, it's actually your electron interacting with a positron to give you 2 gamma ray photons. This is what annihilation actually is. So the names of the particles that are involved in your annihilation process is really just an electron and a positron. Okay, so this is so far okay, right? Then after that, there's a calculation involved here. So I'll go through that calculation with you. This one will be in the next page. Okay, for the next page, this relates to your calculation. Calculate the total energy released in one annihilation event in B. So the keyword here to note is the total energy. Okay, so the total energy here refers to the energy of 2 gamma photons. Okay, because during your annihilation process, by right, you are producing 2 gamma photons, right? So when they ask you what's your total energy that is produced during the annihilation event, it's really asking you about the energy of the 2 gamma photons. All right. So during your annihilation process, your electron and positron, they annihilate each other, their masses disappear and is converted to energy, right? So in your case, if you're going from here to here, your mass was converted to energy. Therefore, you can use E is equals to delta mc squared. All right. So in your case, they want the total energy, meaning to say you are going to consider for both of these gamma ray photons, right? So right now, if you use E equals to delta mc squared, the mass involved must be the mass of the 2 particles, the electron and your positron. Okay, your electron and positrons will have the same mass. Okay, because just now I told you that antiparticle they tend to have same mass but opposite charge only, right? Okay, so when you're talking about your electron or positron, the masses are really just the same. You can just use the mass of an electron itself, right? So this one will be 2 times 9.11 times 10 power minus 31 times 3 times 10 power 8 square 8. You will get the final answer as 1.64 times 10 power minus 13 joules, right? So this is for C part 1. Okay, then you move on to part 2 there. Now for part 2, calculate the wavelength of each gamma photon release. Okay, so this one you need to be careful now. They are talking about each gamma photon. The one before this was really referring to 2 gamma photons. This one is referring to 1 gamma photon. All right, so you're talking about wavelength right now. and you have energy involved here, you obviously will use the equation for photon energy, where energy of photon is hc over lambda. All right. So right now, one thing to note is that this one is supposed to be energy of 1 gamma photon. Okay, this energy that you're talking about is the energy of 1 gamma photon, which by right should be half the total energy that was produced during the annihilation process. Okay, so that's why here, if you continue on with the working, the energy of your photon here is actually E divided by 2. You take the energy, total energy that you got from the previous part, half it, that one will be the energy of your gamma photon, 1 gamma photon only. Okay, so that equates to hc over lambda. Then you just sum in your values, all right? So E is 1.64 times 10 power minus 13 divided by 2 equals to Planck constant 6.64 times 10 power minus 34 times speed of light divided by your wavelength. Your wavelength is thus 2.43 times 10 power minus 12 meter. Okay, so this is for this question here. All right, then you move on to the last part. This one is actually asking you how you actually use your gamma photons to produce an image. All right, explain how gamma photons are used to produce an image. This is for 3 marks. So the complete answer, that is more than what is required, is actually this one. You can first say that during annihilation, the 2 gamma photons that are produced travel in opposite directions. This one was actually worth 1 point. These gamma photons are detected outside the body by your detectors. This is worth another point. And then after that, the gamma photons arriving at the detector at different times allow the location or production of gamma to be determined. This statement alone is already worth 2 points. Okay, the gamma photons arriving at your detector at different times is 1 point. The allowed location of production of gamma to be determined is another point. All right, and then the last one that you can actually say here to finish off the question is that thus an image of tracer concentration in the tissue can be produced. This is another point here. Okay, right? So that is for this question here. For the first time that it came out is pretty straightforward. Okay. Then after that, if you're okay with this, let me move on to the next question. All right. This one, the next one ought to be, just let me find out where it is. Okay, next one should be under page 5. Sorry, not page 5, page 61 of your worksheet. All right, page 61. This one is June 2022 P42. Question 2b. Positronium is a system in which an electron and positron orbit with the same period around their common center of mass as shown here. Then they show you this diagram. In part C here, positronium is highly unstable, and after a very short period of time, it becomes gamma radiation. Describe how gamma radiation will be formed from the 2 particles inside your positronium. So they already did mention to you that your positronium has an electron and a positron that are orbiting around some center of mass. So how did the 2 particles here actually give you your gamma radiation? How did they give you your gamma ray photons? So you have to kind of relate it to the annihilation process. So this one, you need to write a few things. You need to first say that an electron and positron interact. Since positron is the antiparticle electron, annihilation occurs for the pair of particles. All right. So the part where you say electron and positron interact is 1 point. Positron is the antiparticle, electron is another point, and annihilation occurs for the pair of particles. This is another point. You need to specifically mention this annihilation. All right. Then if you're okay, move on to part 2. Now, part 2 state one medical application of the process that has been described in C1. So the medical application is obviously just going to be PET scanning. All right. Okay, so this one is okay. This is pretty straightforward. The PET scanning questions actually didn't come out all the time, right? You notice that this is June 2022 P42, right? It actually didn't come out in variant P41, all right? Then after that, you move on to the next and last question. This one should be page 62 of your worksheet. Okay, so have a look at page 62. This is November 2022 P42. Again, it doesn't come out for all your variants. It only came out for 42, not 41. In your current question, positron emission tomography PET scanning involves the detection of gamma radiation in order to identify the position or origin of positrons in the body. Or in other words, the location of your tracer. So in the first part, positrons are not naturally present in your body. Explain how positrons come to be present in your body during PET scanning. All right. So how did they suddenly have positrons in your body? As mentioned just now, you had to specifically inject a tracer that contains beta plus particles, that emits beta plus particles into your body. All right. So in your case, a tracer containing beta plus emitter is introduced into the body. This one is worth 2 marks. Your first mark comes from you mentioning that you use a tracer. And then the second mark comes from you saying that it contains beta plus emitter. This is your other mark. Okay. So if you're okay, then we move on to part 2. All right, then you move on to part 2. Explain how positrons cause the emission of gamma radiation from the body used during PET scanning. All right, how did your positrons actually cause you to have gamma rays being produced? So this one again will relate to your annihilation process. You would have to say that a positron interacts with an electron so that annihilation occurs. The mass of the particles is then converted into gamma photons. Again, this is worth 3 marks. If you say a positron interacts with an electron, 1 mark. Annihilation occurs, another mark. Mass of particles converted into gamma photons, that is the remaining mark. Okay, so this one should be okay. Okay, then we move on to the last part, and we're going to be done with PET scanning already. This one is regarding calculation, is worth 4 marks. So here, you read through the question, show that the wavelength of the gamma radiation that is detected during PET scanning is approximately 2.4 picometer. Explain your reasoning. Okay, so think about it. If you have an electron interacting with a positron, that in turn gives you your 2 gamma photons. All right. Right now, you want to find out the wavelength of one of the gamma photons. Right? You want to find out the wavelength of the gamma photons that are being emitted. So just now, as I mentioned to you, this electron and positron, they annihilate. They give you these 2 gamma photons, where you say mass is converted to energy. And then you can use E is equals to delta MC squared. Right? This was annihilation for your case. All right. So right now, they ask you to first explain your reasoning when you want to do your workings here. Your reasoning is this: annihilation of electron and positron produces 2 photons. This is where the mark came from, the reasoning. Annihilation electron and positron produces 2 photons. Now, because annihilation electron and positron produces 2 photons, you were supposed to be able to then conclude that 1 photon comes from the mass of either an electron of positron itself. Okay, meaning to say, if you're talking about this photon, it probably came from this electron here. And then when you're talking about this photon, it probably came from this positron here. Okay, so right now you can actually say that one photon is actually converted from the mass of either an electron or positron. So when you want to then use your equation E is equals to delta mc squared here right now, if you're talking about for energy of a photon only, okay, for energy of a photon only, the mass involved is just the mass of one electron. Okay, here you don't use the two masses. The previous one that we did in the first part, we used two masses, right? Because that time we were talking about the total energy that was released. But now, since we're talking about the energy of a photon only, the mass that you really just want to consider is really just the mass of one electron, which also works out to be the mass of your positron. All right. So here, if you use E equals to delta mc squared, your E is hc over lambda. This is energy of photon. The delta mc squared, your mass change is just the mass of one electron. Okay. So from there, all you're just left to do is to sub in all the subsequent values. Time constant, speed of light divided by wavelength equals to mass of electron times speed of light squared. So that eventually lambda is 2.43 times 10 power minus 12 meter. You want to change it to picometer, you just need to divide by 10 power 12. Then you are going to get, wait, no, you don't divide by 10 power 12. You divide by 10 power minus 12. Then you're going to get the final answer as 2.43 picometer. Okay, so that's it for PET scanning. These are the only questions so far that relates to PET scanning. Okay.